All right, to start this lesson, we're going to do review. So I'm going to just review with you what we know. And we know how to find missing sides and angles of right triangles. And to do this, this is what we use SOHCAHTOA for. So when we have a right triangle, we can use sine, cosine, and tangent in order to find missing sides and missing angles. For example, we have this triangle here. We have an angle of 32 degrees. We have a side opposite, and we also have a hypotenuse, meaning in order to solve for the hypotenuse, we can use sine of 32 degrees equals 11 over x. And then as we solve this, we end up with x equaling 11 over sine of 32 degrees. When we plug that into our calculator, we get that that missing side equals about 20.76. Same thing here. In this case, we've got our 64-degree angle. We have an adjacent side, and we are looking for the hypotenuse. So with adjacent and hypotenuse, we would use cosine of 64 equals 3 over x. So x is going to end up equaling 3 over the cosine of 64 degrees. We plug that all into our calculator, making sure it is in degree mode, and we get that that missing side would be about 6.84. We also use, when we have right triangles, sine, cosine, and tangent in order to solve for a missing angle. So here, we've got our angle theta, we have a hypotenuse, and we have an adjacent angle. So we can also use cosine for this. Cosine of theta will equal adjacent over hypotenuse. To solve for a missing angle, we want to get theta by itself, meaning we are going to use the inverse cosine. So theta, what we'll put into our calculator is inverse cosine of 18 over 23. Again, making sure we're in degree mode. When we put this in, we get that theta equals about 38.5 degrees. We can do the same thing with this one. So here's our reference angle theta. We have an opposite and an adjacent. So we'll use tangent of theta equals 39 over 20. To get theta by itself, we'll take the inverse tangent of both sides. And we get that theta will equal inverse tangent of 39 over 20. Plug that into our calculator, and we get that theta would equal about 62.9 degrees. Now, if you are asked to solve the whole triangle, that means you have to find all sides and all angles. So we're going to solve for every angle here. First thing we can do is find angle B. We know that a triangle has 180 degrees. So if we start with 180, subtract our 72-degree angle, and then subtract our right angle, which is 90, we get that angle B is equal to 18 degrees. So we can plug that in here. But now we can also find our sides. Let's use our reference angle of 72. We can find this side x, and we can find this hypotenuse h. But first, let's start with x. So we'll say sine of 72 degrees equals the opposite x over the adjacent 15. So sorry, this should not be sine. This should be tangent because we have an opposite and an adjacent. So then 15 times the tangent of 72 degrees will equal x. So that opposite side is going to equal 46.17. So we can write that in here. 46.17 goes here. And then we can find h. Because this is a hypotenuse, we have an adjacent and a hypotenuse with 72. So we'll do cosine of 72 equals adjacent 15 over that hypotenuse h. So h would be 15 over cosine of 72 degrees. And that h side would be 48.5 approximately. So now we've solved all sides and all angles of this triangle. Now, the part that we get into today is what if we don't have a right triangle? Because that will come up. Sometimes you'll have a triangle like this. There is no right angle here. We cannot use Pythagorean theorem. We cannot use SOHCAHTOA because we don't have a right triangle. So for this, when we have two angles and a side, or two sides and an angle, we can use what's called the law of sines. So here's when we can use it. Number one, no right triangle. If you have a right triangle, you should use sine, cosine, tangent. If you have no right triangle, then we can switch to looking for law of sines. So step one, no right triangle. Step two, if you have either two angles plus one side given, so for example, this one up here has two angles and one side, or if you have two sides and one angle given, you can use the law of sines. The other thing that we need to remember, I'm going to make this a little star, is that sides or angles of a triangle add to 180, because sometimes that will be helpful for us to find what we need. And we can have no more than one obtuse angle. And an obtuse angle is anything greater than 90 degrees. Okay? So greater than 90. So only one. If you have more than one, then you don't have a triangle. So you're kind of always watching for those situations. So the law of sines says this: we name our angles. We name triangles, like this would be called triangle A, B, C. And we use uppercase letters to name the sides. Then we name the side opposite each angle with a lowercase of whatever letter that is. So if this is angle A, the side opposite angle A is side A with a lowercase a. Same thing with B and C. Here's what the law of sines says. It says that the sine of angle A over the side opposite that angle will be equal to the sine of angle B over the side opposite angle B, or side B. And that's also equal to, actually I'm going to do these in the same color, sine B over B, also equal to sine of angle C over side C. Now, you can put these in any kind of order, and you only need two to be able to solve. So you only need two sets. So you could have like this, or you could have this and set those equal to each other, or you could even have this. So any sets of two you can use to solve. And they don't always have to be A, B, and C. You just have to have sides and angles in sets that you can work with. So for example, this is the one that we had on the last slide. We have this 104 degrees across from angle X. And we have this 47 degrees, sorry, not angle X, side X, 47 degrees across from side length 15. So we have two angles and we have two sides. One of them we have to find, but we can use the law of sines to solve this. So we're going to say sine of 47 degrees over the side across from it, which is 15, is equal to the sine of 104 degrees over the side across from it. Then to solve a proportion, because now we have two fractions that equal to one another, we cross multiply. So 15 times the sine of 104 degrees equals X. So when we do this cross multiply, X times the sine of 47 degrees. Then the last step, to solve for X, we would divide both sides by the sine of 47 degrees, which gives us that X equals approximately 19.9. Be careful when you put your stuff into your calculator. Number one, that it's in degree mode, and then number two, that you end your parentheses around your degrees before you push enter, because your answer won't be correct if you don't. Okay, looking at a couple other examples. Here we have 42 and our opposing side. And then we have 28, but we do not have the opposing angle measure. So we have to find this angle measure, and the way we can do that is using the fact that we know that a triangle has 180 degrees, subtract the two other angles that we know to get that missing angle measure. So when we do 180 minus 42 minus 63, this missing angle is 75 degrees. So now we have what we need to set up our proportion. The sine of 42 degrees over x will be equal to the sine of 75 degrees over 28. Cross multiply, and we get x sine 75 equals 28 sine 42. Divide by sine 75, divide by sine 75. We'll plug this into our calculator and we get that x equals about 19.4, and the units of these sides are in feet, so we have to put our answer in feet. This one, we need a little more information, so we're going to use this. I'm just going to give this to you to help you solve. Now, from here, we've got our side given, but we don't have the angle across from it. So we're going to solve for this again, doing 180 minus 32 minus 35, which gives us this angle measure as 113 degrees. And then we've got our 35, and we have our side across from 35, which is x. So we'll set up our proportion. Sine, with law of sines, of 113 over the side opposite equals sine of 35 degrees over the side opposite. Cross multiply. 14 sine 35 equals x sine 113. Divide by sine 113. And we get that x equals approximately 8.72, and this is in yards. All right, for this one, we have a pilot beginning a flight, traveling 80 miles northwest to avoid a storm, makes a turn and returns to his original location. A diagram of his flight course is shown. Find the total distance of the flight. So for this, we are going to actually have to find each side and add them all together. So ultimately what we're doing is we're finding 80 plus x plus y, because that's our total distance of our flight. So we have to figure out all the sides and then add them all together. So first step I'm going to do is I'm going to solve for this missing angle, because that's probably going to end up being helpful for us. So if we do 108 minus the other two angles, we get that this angle equals 57 degrees. So let's start by solving for x. We have sine of 15 degrees over x will equal sine of that angle we just found, 57, over our given side, which is 80. Cross multiply, x sine 57 equals 80 sine 15. Divide by sine 57. And we get that x equals 24.69 miles. Okay, and then let's solve for y. So for y, we'll do sine of 108 over y equals, and we'll go back to the given side that we had. So we'll do that sine of 57 over 80. We always want to use the numbers we're most sure about, which would be the given 80 and that 57 degrees that we could easily calculate, that we hopefully didn't make any mistakes on. Cross multiply, y sine 57 equals 80 sine 108. Divide by sine 57. And y equals about 90.72. So now, to answer our question, because it asks us for the total distance of the flight, we would do 80 plus x, which is 24.69, plus y, which is 90.72, which altogether equals approximately 195.4 miles round trip. So around that entire triangle. So then we get to the ambiguous case, which is everybody's favorite. So this is when we are finding a missing side or angle. When we are finding a missing angle using the law of sines, it is possible to have 0, 1, or 2 solutions. If you are given 2 sides and 1 angle and you're looking for another angle, there is a possibility, based on the information that we're given initially, as we look at it and sort of identify what's going on, there's a possibility that different things could happen. So it is important that we draw the triangle consistently every time. And the way that you're going to draw it is like this. So you're going to draw it with 1 hanging side. Okay, and you're always given, so you're given 2 sides, so you'll be given a side, make 1 side here. You will be given an angle, and you will typically be given the side across from that angle. So, perhaps this is angle A and side A, and we'll just call this side C. You want to draw your triangle like this every time, no matter what letters you're given. If you have 2 sides and an angle, you are going to draw it like this. So your angle will be in the corner. The side across from your angle will be the hanging side, and the other side you're given will be the fixed side that makes part of that angle that you're given. Okay, so draw it the same every time, because what happens here is there are 3 different things that can happen. We could either have that side continue to hang and it will never create a triangle. So that would be no triangle. So this is a possibility that when you are given a side, the length might not be long enough, and then no triangle would exist. It's possible that that side is long enough and it creates a triangle that's fine, right? Like it's just one triangle that exists and that's fine. It is possible that that side, that hanging side, ends up being the same height as the height of the triangle. So when it swings in, right, it could create a right triangle. Then we have a situation where it could possibly create 2 triangles. So if it is longer than the height and shorter than the other side, so shorter than this side here, but taller than the height, then there are 2 things that could happen. So when that happens, there are 2 possible triangles. So you can have one possible triangle here, creating a larger angle at the top, or this side could potentially swing in and kind of go this way, go past the height, and create a triangle here. So we could have 2 possible scenarios that have the same side length. So like this side length is the same here and here. Just what's different is going to be the angle measurements here and here. So we have to take those both into account if that's the possibility. So there's kind of a series of checks that you go through to see what is happening with your triangle. So again, we always start with our drawing like this. So we have our side that we're given, our 2 sides that we're given, and we have our angle that we're given. We always draw this side across from the angle. We're going to make that our hanging side. So if I was doing this problem, then I would make this angle kind of look like this. It's not going to erase for me, but I would hang this 11 side. So, and then I would draw in my other side that I'm given that's not the side across from my angle, making a part of that angle. So we're going to always call this value A, and this is always our wild card. This is the one that we're always checking for. We're going to call this one our C, just for the cases of our checks. So when you're given a problem, it might not be A and C, but you're always comparing the lengths of those 2 sides. So if your A value is greater than or equal to C, then you just have one triangle and no ambiguous case. So there's no ambiguous possibility. You're just solving this regular law of sines. There's one potential triangle that exists, and you're just going to solve for it. So that is, this example up here is one of those, because our a value 11 is bigger than 10. So we would just go about solving this using the law of sines for whatever we needed. Now, if a is less than c, so if this side here is shorter than your sort of fixed side that you wrote in, then we have to do some more checks. So we compare that side of A to the height of the triangle, okay? And to find height, this is on the next slide too, but I'm going to put it here. Height equals C, this value, times the sine of angle A, whatever that might be. So this is something that you would put into your calculator, and you'd get a value for the height, and then you compare it to A. Here, that if A is greater than C, if that hanging side is greater than the fixed, if A is less than C, then we have to compare that value to. All right, so this is a picture of the animation. It's not letting me sort of use this to animate it, but this kind of shows what's happening with the ambiguous case when we have a value that's greater than the height. So if this here is our height, and this is our side A, our side A, notice that this can swing and create two possible triangles. So we could either have a triangle like this, or we can have a triangle like this, because that side could make two different possibilities as it swings back and forth. Okay, so like that sort of shows you visually what's happening, but we're going to calculate this so that you can maybe get an idea. But this is kind of a helpful tool, I think, to be able to see what's happening with this ambiguous case. Okay, so we have either an obtuse angle here, if we're going to use this side, or if we're going to use the other side here, we would have another triangle that has an acute angle up there and an obtuse angle down here. So we'll talk about how to find that when we find. So like if we go back to this, if your side length ends up being exactly the same as the height, then you have a right triangle, and you're just going to use SOHCAHTOA to solve whatever you need to solve. So that's our other possibility. To this, if our A value, if this is our height, if our A is less than this, it'll swing, but it's never going to catch any of the bottom part of the triangle. So you're never going to close the triangle, and you'll never get back side. A little reference slide, height reference slide. Check out the little rules here. If A is greater than the height, so this is kind of worst case scenario. This is like where you have to do a lot of work. Two triangles. And when you have two triangles, you must list all the possibilities. Okay, so this is that swinging side like we just saw that's creating two possible angles to a problem like that. If A is equal to the height, then you have a right triangle, which you can then just use SOHCAHTOA to solve. You don't have to use law of probability. The third possibility is that if A is less than the height, you will have no triangle. So if we go to shape, so there's no triangle. And the way we find the height in order to compare is we take C, the fixed side, and multiply it by the sine of angle A that we've been given. We have to our, if A is less than the height, we do not have. All right, let's do a couple examples. This one says solve the triangle. So I'm going to zoom in a little bit. It'll let me. Okay, I'm going to start by drawing this. So we are given, let me do this in black, our triangle. And we're always going to sketch it the same way. We are given an angle, so 41 degrees. And the side across from that angle, which is going to be our hanging side, as well as our fixed side. So our first step is to compare these two. And in this case, 25.9 is less than 38. Actually, I think I wrote it the other way. Let's always do A first. Let's do A, so our short side, or our little hanging side, is greater than 25.9. Have one triangle. So essentially, this side just comes down here, and we're done. Like, we don't have to worry about the ambiguous case. So what we're going to do is just use law of sines. We have our angle and our side across. So law of sines says that sine of 41 over 38.4 equals sine, I'm going to call this x, sine of x over 25.9, cross multiply for sine x equals 25.9 sine of 41. Divide by 38.4. So those cancel. The last thing that I have to do, because I'm looking for an angle, so I have sine x equals 25.9 sine 41 over 38.4. To get x by itself, I take the inverse sine of both sides. So what you're going to do is do inverse sine, because that'll get x by itself, so that we can solve for that angle. So x equals about 26.26 degrees. So I can plug that in here. 26.26 degrees. I need to solve, I can find the third angle just by doing subtraction. 180 minus 41 minus 26.26, which will give me the angle of this, or the measure of this top angle. Did I do that? Which is 112.74. Okay, and then I'm not going to do it here, but like in order to find this last, so in order to find the last side, we would just use law of sines. I'm not going to work the whole thing, but now we have all the angles, and essentially what we're looking for is just this last side down here. So we would be solving for this. So if we called that y, and we could use law of sines to solve that. So depending on what you're asked for. All right, let's look at number 2. So we have an angle, B, and we have the value across from B. So I'm going to start by drawing my little triangle with a hanging side. If this is B, then this is little b, and they tell us that A is 859. So we are going to sketch in the triangle just like this, with A being our fixed side, B being our given angle here, and our hanging side being across from the angle we are given. So the first thing that we check is we compare the hanging side to the other fixed side. And in this case, 783 is less than 859. And if we look at the height of this triangle and compare it to that hanging side to see if we even have a triangle at all to work with. So to find the height, we take the fixed side and multiply by the sine of the angle that we were given. So the height of this triangle is 825.7. So 825.7. If we go a triangle side, is it's going to swing, and it's never going to be long enough to catch any part of the bottom. So our answer is no triangle exists. Because what's going to happen with this, finally, everyone's favorite, I'm sure you can tell what's going to happen here. So here's what happens. First, if we sketch our triangle, here's our little map. So if this is A, we know the measure is 29.7. So the side across from it is going to be 27.2. And our fixed side, which will be B, is going to be 41.5. Step 1, compare these two. 27.2 is less than 41.5, meaning we have to compare to the height. So the height is going to be 41.5, so our fixed side, times the sine of our given angle. So the height of this triangle is 20.56, meaning this side is greater than the height, and when that happens, there are two possible triangles. So let's look at these two triangles. I'm going to do triangle 1 first. Triangle 1 is here. And this one is going to look like this. So it's going to have our like obtuse angle. This is still 29.7. This is 41.5. And this is 27.2. So we close off. This is A. This is little a. They told us this was B, meaning this is big angle B. And this is side C, angle C. So we can solve now for all of the sides and all of the angles in this triangle using the fact that we know that this is going to be the obtuse angle up here. All right, so let's go ahead and start with, let's find angle B. So let's find angle B since we have a side across from it, so we can use law of sines to find angle B. So we're going to say sine of A, 29.7, over side A is equal to sine of angle B over side B, which is 41.5. Cross multiply. And then take the inverse sine of both sides to find what the measure of angle B is. And if we plug this all into our calculator, we get that angle B equals approximately 49.1 degrees. Okay, now that I have two angles, I can find angle C by just subtracting 180 minus 29.7 minus 49.1. So this angle C is approximately 101.2 degrees. The last thing to solve for is side C. So I'm going to do sine of angle C over side C equals, I'll go back to A, sine of 29.7 over 27.2. So then cross multiply C sine 29.7 equals 27.2 sine 101.2, and then divide by sine 29.7, divide by sine 29.7. So we get that C, put that all in our calculator, equals 53.9. So now we have every value from that one triangle, but there is another possibility for this triangle. I'm going to add another slide. Okay, if we go back 20, so our other triangle would look like this. If we swing that side in, okay? So this is still 29.7. This side across is still 27.2. It has just swung in, and our height is here now. And then this side B is still 41.5. So nothing about that changed, but what has changed is just the angles in this, on the other side of the triangle. So these are just going to be slightly different. So here's what we're going to do. We can make another triangle here using these two sides, right? So this is going to be an isosceles triangle on either side of the height, meaning this side was 27.2, this side is 27.2. And so what we can do is we can pull this little triangle out. This is a right angle. So we have a 30-60, not 30-60, a right triangle with a hypotenuse. And we also know the height, 0.56 is what we found here. So what we can do is we can find the measure of this angle here And if it's the measure of that angle, it's also the measure of this angle. So if we use just sort of laws of SOHCAHTOA, here's our reference angle. We have an opposite and an adjacent. So sine of this angle theta equals 20.56 over 27.2. Take the inverse sine in order to find the measure of that angle, which is 49.1 degrees. So this is 49.1. So this is 49.1 because it was isosceles, meaning this angle in here, since this is a straight angle, it totals 180. 180 minus 49.1 means this angle inside here is 130.9 degrees. So if I label this again, remember this was A, this is C, this is B. So angle B is 130.9, meaning we can solve for angle C by subtracting 180 minus 130.9 minus 29.7. So angle C would be 19.4 degrees. So now we have all three angles in our new one. We just need to find the sides, and we can use law of sines for that. So sine, using side A, 29.7 over 27.2 is equal to, well, actually, the last one we have to find is just side C because we have B already. So we know the measure of angle C now, sine of 19.4 over C. So cross multiply, C sine 29.7, divide both sides by sine 29.7. Put that into your calculator, and we get that side C is about 18.2. There is one more slide on here that I'm just going to skip because I think we are at the point of exhaustion. So as long as we got the ambiguous case, that's what I'm good with for now. We'll go over the word problem another time. Oh.